Hey Evan, I have one of your quiz attempts here. I think this is the first one, so we're going to go over this one first. I like to go through the questions that you missed and see if I can just kind of clarify or clear some things up a little bit. So this first one is the race where Corinne and Aretha are running, but Corinne gives Aretha a head start. And so Corinne's information is in the table and Aretha's information is here on the graph. And so what the question asks is how many minutes after the start of the race does Corinne catch Aretha? And so when we talk about rate of change, we want to make sure that the relationship is proportional. And if it's not a proportional relationship, then we have to try to figure out what the rate is. And so in this problem, you can see that Corinne takes her 10 minutes to run 1.25 miles. So if we take 1.25 and divide it by 10, we get 0.125. This is how many miles she runs per minute. It's always the y divided by the x. This works fine here because Corinne does start at the start line. So at 0 minutes, she's gone 0 miles. It's a little different here for Aretha because she actually doesn't start at the start line. She doesn't start at 0. She gets a 3.5 mile head start, which is what it set up in the problem. So at 3.5 to, let's see if I can kind of estimate where that would be on the graph. That's about 3.5. That's where she's starting. And so if we talk about what her rate is, how many miles she runs in a minute, we can see that it takes her 10 minutes to run a mile. So from 4.5 miles to 5.5 miles, she went from 10 to 20 minutes. So 10 to 20 minutes, she went from 4.5 to 5.5. I'm just looking at those ordered pairs. So her rate, 1 mile every 10 minutes is 0.1, or I guess I was going to put 0.10, but it's just 0.1 miles per minute. And so it wants to know when they're going to catch them, so or when they're going to be at the same distance. So if we set up an equation or write equations for both situations, Aretha runs at a rate of 0.1 miles per minute, and she started at 3.5 miles. Corinne, on the other hand, runs at a rate of 0.125 miles per minute, but she started at the start line, so we don't have to add anything to her distance. What we want to do is essentially set these two expressions equal to each other and then solve for x. So we're going to subtract 0.1x from both sides. That's going to give us 3.5 equals 0.025x. And if we divide both sides by 0.025, we get that x equals 140 minutes. So it will take Corinne 140 minutes to catch Aretha. Question 5 says, a linear function graph below represents the height of a stalk of corn. Since a farmer began using a new fertilizer, what is the initial value? And we can just kind of work backwards here on this table. As you can see that every day the flower grows 2 feet. So on day 3 it was 10, on day 4 it was 12, day 5 15, and day 6 16. So if we just work backwards, if we subtract 2 feet, on day 2 it was 8. On day 1, this is like 1 day later, that's what that means, or after 1 day of using it, and so day 0 would be here. So that's 4 feet would be the flower or the stalk of corn's height at the beginning. Question 6, the table of values below represents a linear function, shows the amount of money in a tip jar at a dry cleaner. Since the dry cleaners open for the day, how much was in the tip jar when the dry cleaners opened? And so again, a couple of different methods here really to solve this, but if we look at how much money is being tipped every day, so if we take 18.25 and subtract 15.50, we get $2.75. So you could work backwards. We could look at day 3, we could look at day 2, we could look at day 1, and we could look at day 0. So if we just continue to subtract $2, whoops, I said 75 and I wrote 50. If we just want to continue to subtract $2.75 starting here, so 1550 minus 275, so day 3 it was 1275, minus 275 is 10, minus 275 is 725, and we got to get all the way to day 0. That's the starting point. So it looks like you went to maybe day 1. We got to subtract one more time, and that's going to give us $4.50. Table of values shown below represents a linear function. Which of these points could also be an order pair in the table, and why? And so when we look at proportional relationships, linear functions, we know that the rate of change is going to be the same throughout the entire table. So it's asking you which ordered pair fits in there. Well, you can see that the x's are smaller than the y's, so that kind of rules out these 2 points at the bottom. So then the question is, what is the rate of change? Let's actually do the calculation. And so what we're going to do here is I hope that they've shown the formula y1 minus y2 over x1 minus x2. This is how we just calculate this. So if I take the second and third ordered pairs, you can take any 2 ordered pairs you want. If I do 11 minus 7 over 6 minus 3, I get 4/3. It's always the y's on top and the x's on bottom. So in the answer choice, you have the right ordered pair, but you have the x's and the y's flipped. So just make sure that when you're calculating these rate of changes that we always put the y's on the top in the numerator and the x's in the bottom. This question says the table of values below represents a linear function, shows Marco's progress as he's pumping gas into his car. What's the output for the initial value? So that's when x is 0. You can see here when x is 0 that y is going to be 3. So he had 3 gallons of gas already in his car before he started pumping gas. In a horizontal table like this is always the x and this is the y. The x's are your inputs and the y's are your outputs. So that was asking you, what is the y value when x is 0? Okay, let's go ahead and look at that other attempt. Okay, 4 questions here to go over. Eric received a gift card worth $25 as a birthday present. He's spending $2.50 per day using the gift card as shown below in the graph. Which statement is true? The initial value is the amount on the card before Eric starts using it. That is true. The initial value is the initial means like in the beginning. The initial value is the amount of the gift card after Eric finishes using it. No, that would be at the final value, I guess, the end. Rate of change is the amount. Nope. The rate of change would be how much he spends per day. When we talk about rate of change, it's always the y's over the x's. So it's or how much he spent or how much is left on the card per day. That's going to be your rate of change. So initial value means in the beginning. So that's why this answer choice is correct. Linear function again. Tim's age in the years since he was married. What's correct? The initial value is 22 and the rate of change is 1. So for every year he's married, he should get a year older. That should be true. But his initial value isn't 22, I don't think. No, because after 22 years of marriage, he's 54. Initial value is going to be on this y-axis. Okay, your initial value is always somewhere here on the y-axis. We kind of have to work this line backwards to figure out where did it actually start. So it looks like 22 years of marriage, he's 54. 37 years of marriage, he's 69. So if I do 69 minus 54, And 37 minus 22, that's 14 over, right? No, 15. 15 over 69 minus 54, 15, 37 minus 22. Yeah, the rate of change is 1. Okay, duh, that makes sense, right? Every year you're married, that's another year older that you are. So the rate of change is 1. So if we go back to 0 years of marriage, we're taking 22 years off of that because this is where it starts at year 22. So if we want to go all the way back, we would subtract 22 from 54. And 22 minus 54 is 32. If the rate of change was 15, like in the answer choice you selected, that would mean that he gets 15 years older every year that he's married. We can make a lot of jokes about that, right? Being married maybe makes you feel like you're a lot older than you really are. But here it is. Every year he's married, he does get a year older. So again, if we start this graph at 22 years married, we would have to subtract 22 to figure out 0 years married, and then we would also subtract 22 from 54. That's what I did there. Okay, a couple more. This one says, oh, this is the same one we already did, right? So this one was a little harder, right? We had to find both rates of change. How many miles did they run in a minute? And then recognizing that Corinne was getting ahead, or Aretha was getting a head start, and then setting those two expressions equal to one another and solving to figure out when was x the same, because we used x for minutes and our distance was the y. And we already went over number 9. This one was also in the last quiz. So I'm going to go ahead and give you another attempt. I think you get 3, but I'm going to go ahead and add another retake on here in case you do need a couple. I know it's the weekend, so sometimes I'm not as quick to get back with you. So shoot me any questions you have. I know your mom mentioned maybe we can set something up where we're meeting or chatting once a week or twice a week just to kind of go over things and make sure that we're understanding everything. This is the way a lot of students do it. They'll just reach out when they are struggling, and then I can kind of make a quick video like this. I just kind of happened to be home for a few minutes this weekend and got out my computer real quick to help you out. So let me know if you have any other questions, and hopefully we can schedule something so we can start meeting weekly. Talk to you soon. Have a good weekend.